this message for all, but please let us know if the content is too basic for some or too detailed for others. Then we will have possibility to adapt our content for next edition. In order to create some interaction with you, we will push 4 polls during this webinar to get your feedback live. We thank you in advance for your active participation. Your questions are welcome through the question panels or by email, camfil.webinars with a S at camfil.com. So, my name is Fabrice Dorchy. I'm leading the European engineering team. I've been in the HVAC industry for more than 20 years, with many of those at Camfil, at several executive positions from sales and marketing to product development. I'm married, I have 2 boys, and I love skiing.
And my name is Volker Parcoin. Hello, everybody. I have been with Camfil for 6 years now and with the EMC, the European Metal Center, from the start 4 years ago. I have a double role as Product Manager Europe for metal products and as technical support, both internal and external, for customer requests. And in my free time, I enjoy a few very different hobbies, things that keep my hands busy.
So, what are we going to talk about? As you can see on these pictures, we're going to talk about housing for clean room equipped with HEPA filtration. Today, we will look at Camfil terminal and BIBO safety housing for use in clean room and control environment. These investment goods are a crucial counterpart to the actual HEPA filters for any air filtration solution. Regarding the agenda, first we will start with a few words about clean rooms, containment and BSL, before we share challenges related to capital equipment project cycle. Then we will focus on ensuring compliance with standards and with pragmatic requirements, with particular attention to the aspect of chemical resistance to decontamination agents. That will be followed by characteristic of housing for controlled environment and a selection. Then we will share with you some practical customization example, and especially for terminal HEPA housing and BIBO out examples. To finally close this 1-hour webinar with the latest tendencies from the markets. So, we are interested in containment for some of the following reasons. Reason number 1, we need to protect people from the product. Or we have to protect the product from the people. Or to protect environment from the product. Plus other basic cases of cross-contamination between product or between people. Level and needs for containment will of course be different regarding application from one application to another. Containment in use BSL and general laboratories area. Containment are mainly used in BSL. We found them in companies of different sizes, from very small to very large, universities or public research center, military research centers. Safety labs are classified in 4 classes. The lower the class, the more labs are existing in various countries, and the higher the class, the more advanced the air supply and exhaust system is. About the BSL classification, so handling of biological or pharma agents means handling all sorts from low risk to high risk. To make sure that each are handled safely, both personal protective equipment and building design safety are increased. BSL are ranked from 1 to 4. Safety level 1, nothing much to say. No restriction for access, no specific air filtration requirements. The next safety level, number 2, means work in restricted area. People shall be informed and trained on the risk. Access to an autoclave is a must. Potential infection waste has to be separated. Possibility to seal and then contaminate the room with H2O2 or other agent decant. Typically, a BSL-free has to be isolated and equipped with observation window. A straight access regulation are required. Supply air and exhaust air must be HEPA filtered. Entry shall be done through an airlock, and the room shall be pressurized compared with the surrounding. Autoclave with the control area, and wastewater might be disaffected. Safety level 4. This is the highest safety level. The personnel works in an airtight safety suit with breathing air equipment that creates another pressure in the safety suit. The room is completely physically isolated. Both in and outlet air is HEPA filtered and duplicated. All wastewater is decontaminated, and a duplex autoclave is located within the control area. Working allowed is not allowed. So we've been talking several times about HEPA devices, but what is it about? This is our BIBO range, BIBO housing range for Europe. Basically, for level 1, CAM boxes offer BIBO door function, welded and bolted construction. It is a basic housing with limited number of options. For level 2 and often level 3, when equipped with some option like tie damper, mobile integrity probe, CAMSafe 2 range fully welded line of product is in compliance with this level. We will go deeper into this CAMSafe 2 range later in this presentation. For safety level above, typically level 4, CAM contained CS is recommended as decontamination port and system, bubble tie damper, and auto scan devices are requested. When we come to the literature related to BSL, we have a lot to say. If you believe a dedicated webinar would make sense for this subject, please tell us, send an email. Before jumping into product and application, let's see why capital equipment projects need a specific approach. We start from initial design and initial specification. But before going from a greenfield to operating pharma plant, a long journey starts. Because redesigning and consideration will generate challenges like cost, time, and technical question. At that stage, project can go in many directions, and this is our surrounding and daily environment. We know by experience it's not a long and quiet river. All stakeholders must bring at least ideas and reactivity. So how can we help at that stage? As project is key, we have set up a European project organization in order to provide, first, a dedicated technical project and installation support in every European countries. One European centralized engineering team where all custom projects are converging. Some existing and coming tools like Creo, Consultant Portal, etc. will come very soon. And a strong segment focus with expert together with 150 sales support. So I take opportunity to introduce the first poll. When working in a control environment project, what is the most important for you? To get a quick availability of a budget pricing, a quick access to product drawing, customization of product, or easy access to past project products. Tell us a little bit what is important for you. Interesting. Thank you for that. So now we can continue with the challenges for the clean room housing and more generally speaking, clean room products. So now we have drawn the environment and the context. Let's come back to the product topic and let's see what challenges these HEPA housing are facing. Number one is of course compliance with standard, but not only. We will show you how we have defined our own protocol to make sure our product resists to decontagion, for example. Number two, operational performances like life reliability, for example. We will introduce you some design aspect of the product. The modularity and flexibility It might be considered as the hidden part of the iceberg, but so useful to match market customization expectation and especially time to market aspect. Because probably more than anywhere else in capital equipment project, time is money. And of course, even if it seems obvious, user friendliness like toolless maintenance product, smart clamping devices, etc. So let's go and see how to face these challenges. So first, compliance with standard and requirements. The main standard our product will comply with are EN 1886 and ISO 10648 in production. And exactly as for HEPA filters, the ISO 14644 will challenge housing performances on site together with the HEPA filter. Of course, a few years of experience from the 60s to nowadays help to comply with requirements. But despite the fact products are airtight by design, as Volker will introduce just later, some products are 100% leak tested, typically the case for CamSafe BIBO housing for BSL environments. Of course, other individual leak tests can be done on request for any housing that include a HEPA filter. As we said previously, we all know individual test reports are mandatory for HEPA filters from 813. But what about for housing? Are test reports available? Other standards need to ask ourselves if housing be certified to ISO 10648 in terms of leak tightness. If we look closely at the standard, we can say that yes, this should be included. So don't forget to check and ask your supplier for this one. Another criteria like OEL for occupational exposure limit are taken into consideration to classify containment product performances. The standard EN 689 takes into consideration the workplace and exposure level. And containment equipment like isolator, glove box, BIBO housing should reach a certain OEB level, accordingly ESPE good practice guideline. Now we are entering a very interesting topic, basically very far from air filtration, but in reality extremely close life science industry challenges. So let's see how housing can resist to decontagiant used in biopharma. First, what decontamination agent housing and filters will meet? Quite easy to answer. But when we talk about concentration or cycle frequency, it really depends from one user to another. In any case, the challenge is the same. We need to avoid this corrosion, providing the accurate coating. Clear? Yes, but how? The climate chamber equipment located in our tech center in Sweden gives the possibility to replicate on-site chemical environment using H2O2 or acid peracetic, for example. Specific sample that replicate housing complexity with hole, cavities, bends, welds, etc. with different coating were put into the chamber in order to define the best coating solution. In close relation to biopharma industry, we have developed a protocol that challenges the solution and is repeatable in any laboratory. Good to know for you, if you are using other decont agents and you would like to know effect on surfaces, please don't hesitate to contact us. The conclusion of all these tests is this series of tests drove us to use to the following coating protocol in 3 steps. Step number 1 is an initial surface preparation, can be chemical degreasing, grinding, sandblasting. Step 2 is a first layer, also called primer, with a minimum of 70 micron gray epoxy layer to ensure a first visual quality check. Many primers are epoxy-based and show excellent corrosion resistance and adhesion strength. They are used as a pre-coat underneath other paint type. The step 3, the final layer, will be a minimum of 70 micro polyester layer chosen for high chemical resistance to decant agent and also UV resistant. The total protection will be 140 micron. Of course, if you are for heavy-duty application in life science like high moisture, low temperature, negative temperature warehouse for bulk vaccine storage, extreme decontamination process, or blood fractioning application, we will require stainless steel 304 or even better 316L. Don't hesitate to ask Certificate 3.1 for stainless steel traceability and proof of origin. We can supply it. Regarding outdoor installation, for application that involve items permanently outside, the sustainable solution is the 316L for a lifetime durability. And now coming to quality control. So what is an HEPA filtration solution? An HEPA filtration solution is a combination of a filter and a housing. We all know that HEPA individual filter test report, but what about housing? What kind of protocol should be defined to make sure what is on the box is in the box? Volker, please, could you tell us a few words about the quality control for housing?
Of course, Fabrice. So about operational quality control or quality checks. Checkpoints and protocol severity are of course defined according to the target application of the respective product. There are dimensional, geometrical and functional checks, all according to a clear product-specific protocol and backed by systematic records, which afford us a full traceability from the individual housing to its production and checking record. But also packaging for efficient transport protection. So what's on the box is not only in the box when we pack it, but it still is when you unpack it on site. And even if they are not a tool of continuous production quality control, factory acceptance tests are quite interesting. We do those for internal requirements, of course, but we do them also on customer requests. This can be organized at the production site or for an extended testing scope, like with live airflow at our laboratory in the Kampfil, Germany production site. If operational quality control is adapted according to the product, there still are some global characteristics of housings for controlled environments that are to us globally valid design principles. And the overall focus here is clearly on long-term reliability, as we think it should be for housings in controlled or otherwise safety-critical environments. Those principles are, number one, we use bending metal forming instead of welding or other forms of assembly whenever possible. That gives us sometimes complex parts, but always mechanically robust parts. Number two, if we have to, we use continuous welding for the containment barrier. This means the housing will be airtight by design. And since there will be no sealant for airtightness, that means it will remain airtight over time, whereas sealants will end up drying out and then give you issues. Finally, the double layer powder coat, we spoke a lot about that. It's for protection in life science environments. But there are other aspects as well. Fabrice, what would you like to say about those?
Well, it's a question of vision now and product development. So the design principles seen above, shown by Volker, are a first step to meet our challenges, but are not sufficient to reach efficient customizing and product consistency. That's why we believe the product dedicated to clean room environment should first be built with a consistent life science DNA in line with HEPA filter challenges. Second, and equally important, embrace a modular design to match flexibility and reactivity expectation. As we previously said regarding project, customization and adaptation is a daily reality, and time is money. No one can wait 2 weeks to get a drawing and a quotation. So this kit approach, combined with consistent product DNA, allows us to bring flexibility out of product family structure, to provide timeline and overall efficiency, and to turn standard modules into custom solution. The takeaway for you and for the market is a customer drawing and a quotation in 5 working days for projects that involve product built in this way. But now, let's have a look at some applications where HEPA housing are well known and we have selected for this webinar. Except nuclear industry and gas turbine, I would say that all other applications of this slide might need HEPA terminal housing and or BIBO housing. But today we decided to focus on product for pharma, life science environment. Typically, we are talking about supply and exhaust air filtration. We are going to have a closer look at the terminal supply air housing, or rather terminal housing for sealing installation, because those are suitable both for supply and extract air. We will also see exhaust air housing, a variant of terminal housing from the same product family, specifically adapted to wall installation. And then next to this terminal housing, we will see the safe change BIBO housing. In this example for air extraction, those exist as a standalone unit or with banks, and as a variant for wall-mounted installation. So we shall start with terminal housing for sealing installation. So let's see the key requirement for that type of equipment. So what is the most important when selecting a terminal HEPA housing? Should be no leaks to keep passing integrity test over the time, validation with easy and quick access, filter installation safe and easy, housing installation safe and easy as well, and the scalability that is an option to increase the filter performance in operation. So I take this opportunity to introduce our second poll of this webinar. So for you, we would like to know what is the key challenge to a terminal HEPA housing. Maintain leak-free, resistance against decontamination agent, quick installation and servicing, or comply with standard. Interesting again. So the leak is the key enemy in the clean room. What a surprise. Okay, Volker, could you please carry on with maybe to answer this leak aspect?
Yes, of course, Fabrice. So the 5 features that Fabrice just presented are actually what we got from our customers a little while ago already, and it is what inspired our CleanSeal concept. So what you will see next are the CAMFIL technical answers with CleanSeal, but we still believe those features are essential in a clean room context. So yes, point 1, no leaks by design, and we really feel our own design principles as presented fully apply here. It should be robust, it should be fully welded without sealant, and then you are leak-free by design, and it's enough to just check proper execution. Point 2, easy and quick access. Well, the front plate locking should be simple, no screws, no tools. If you look at our operator in this little video, you'll notice that the only tool, so to speak, he uses for this clean seal housing is a plastic card, and that can be any plastic card. Like that, he has immediate access to the filter and DP port. And in this instance, conserving a sort of tool for the opening was a deliberate choice, because the front plate must remain safely locked against involuntary opening, for example, during cleaning. Point 3, filter installation. Filter retainers are very useful feature here. Should be ideally adjustable for different filter types. We've seen the issue of filter scaling. There's no need for 3 hands, more realistically 2 persons, for safe filter installation that way. Then the clamping system itself should be easy to operate. With Clean Seal, this is patented and of course toolless. Point 4, housing installation. The housings, never mind the type, should be easy to insert from the room side, with all elements within the perimeter of the cutout. That is helped by removable mounting blocks, and this feature also supports using the same blocks for both suspension mounting and for compression mounting. And finally, yes, filter scalability. This feature is a reality for Clean Seal, with a unique multi-position mechanism that can be easily reconfigured. And it will allow for filter upgrading at any time just by resetting the clamp position. So this feature is particularly interesting because it can impact your life cycle cost. I will let Fabrice give you some practical examples to illustrate.
Thank you, Volker. Yes, that's true. This filter scalability is very interesting. And on this example, if we start from a traditional setup, let's say a 6x6 housing with a standard 66 millimeter H14 filter plus a perforated front plate, we are in a range of 600 cubic meter per hour with 120 Pascal. So let's see how, from this configuration, we can make significant changes with the same housing. So now the energy manager is asking you to reduce energy consumption by X%. So this is what we will call the low energy setup. With the same housing, using a new filter, 110 millimeter, for example, and the same front plate, we have now saved 50 Pascal per housing. Finally, another possibility is to increase airflow by X%, to upgrade, for example, the room from ISO 8 to ISO 7. The same housing, another filter 110 millimeter high airflow, a swirl or 4-way diffuser, and possibility, in theory, to reach 2000 cubic meter per hour with 250 Pascal, remaining H14 efficiency. Of course, pay attention to noise level and pressure drop available with this setup from your air handling unit, but I'm sure you got the point and you will know how to use this flexibility and housing scalability. So we have seen one key aspect, which is the noise level. Another key aspect, of clean room design and by extension air diffusion is noise level. Some segments like hospital are very demanding in terms of low level. So if we combine 3 basic housing design together with 6 front plate types and with 3 filter types, you can quickly imagine the number of combinations we need to deal with. And as extrapolation is sometimes a little bit borderline when we talk noise level, we have to launch a big real-life test campaign in an independent lab to get true figures. So we tested 152 combinations that are available currently on request. So let's see what it looks like. This is basically the graph you will get with different housing sizes on the right. Taking an example for a 6P6 housing, side spigot, 315, perforated front plate, and a 110 mm H14 filter. So for a nominal airflow at 0.45 meter per second, the pressure drop is 74 Pascal, which is relatively low, taking into consideration the pressure drop of the filter. And this configuration generates a 28 dBA noise level as well, relatively low. So this information are available for 152 different setups. Contact your local CAMFIL person to get access.
Yes, after that little excursion into front plates and energy management and upgrading, let's go back to our product selection, and now let's have a look at exhaust air housings or return air terminal housings specifically adapted for wall installation. The same question remains true, of course. What are the key requirements for this system? We think it should be reliable. Above all, it should also be smart, and we'll see in a second what we mean by that. We should have the same scalable HEPA option, identically to ceiling housings. The door should be flush, both for aesthetic and for cleaning reasons, with the option for a additional pre-filter. And it should, of course, be a fully toolless solution. The answer to that can be a standard base housing with optional door variants. That would, in the case of the clean seal exhaust, be a similar concept as the supply air housing, only adapted for wall installation. So at the basis, you get a housing including your scalable HEPA, filter depth 1, 2, 3, flexible, different filter frame heights, plus optionally, by changing the door, a 50 mm G4, G5 pre-filter on top of that. Pre-filter door is fully interchangeable with the standard door at any time. So, and when we say specifically adapted, just two examples. Instead of retainer clamps, those are notoriously useful in the ceiling, but totally unnecessary here, you need an adapted filter support for the wall. And instead of the safe locking front plate, you will need a door with specific features for an ergonomic use in a wall situation. And how does that look for clean seal exhaust? When we say the housing should be reliable, we mean, of course, the features of leak-free by design and corrosion resistance. We just have detailed the topics. I will not going to repeat myself. And when we said it should be smart, of course, we don't mean you should be able to operate it from your phone, but quick and easy access can be much helped with little ergonomic details that effectively support maintenance tasks. And this is how we approached it for clean seal extract. So you have here a secure and fully tool-free door operation. You have not only easy access to the DP port, but also a safe lodging for the door tube so it won't get damaged, or worse, damage the filter during door operation. And the door itself has a stop, useful for any intervention, but that is actually better to see in this little video, where you can see that pre-filter change is a matter of seconds. Thanks to the door stop, the operator has both hands free for the filter manipulation. There's a set of springs ensuring good contact of this M5 filter with the sealing surface of the door. And from the open door position, like so, the door can just be lifted out for access to the HEPA. As far as installation goes, we said, well, this housing should be specifically adapted. And yes, there are specific challenges to wall installation, and especially in terms of access. Our solution here is a optional quick clamping kit, which allows for installation in 5 minutes or less. It consists of 2 pressure plates that can be fixed without any visibility on the far side, thanks to a little visor system, plus a compression bar. The point being, the system requires access from one side only for a very fast and reliable result. And this may be designed for wall installation, but it will work perfectly for ceiling installation as well. Last but not least, in the air filtration systems of such an environment will also find bag-in, bag-out safe change housings. Those are actual safety housings and configurations for containment levels BSL2 up to BSL3, in some cases 3+. Those BIBO systems can be configured freestanding in single, multiple banks, but also as a wall-mounted variant for single column towers. Key requirements for such a containment level housing system. Number one, as the name says it, they have to be designed for durable safety, and fully welded on this level is not an option anymore. They should provide a double safety at filter installation, and we're meaning a fail-safe filter positioning and also a fail-safe clamping. Number three, they have to be designed for BIBO operation, that is mandatory for operator safety. But it also means every operation has to be possible through a thick plastic bag. And that is why point 2 is so important. Ideally, they should also present a modular scope, because from our daily project practice, I really can tell you half of the time it's not going to be so easy and straightforward than what you see on the right side of this page. And the modular product will allow for much swifter and more flexible responses to the complex technical environments. But I stress the importance of point 2, so let's have a closer look at that. When you are interested in investing in a housing, you should have a close, careful look. Remember, with a housing like this, you would typically be working under containment level L2 or even L3 with potentially toxic substances in the process air. So fail-safe positioning should just be mandatory. On the right, you see an example. This clamping lever can be operated right now. But if you look in the back, there's like a 20mm bypass, and this filter is grossly out of place. So that should just not be possible in safety relevant equipment, and it has to be considered a major safety failure. After insertion, well, there's still clamping, and then you want to close the housing. That should also be fail-safe. Here we see 2 examples of filter clamping in the closed position, and if you look closely, they both do have mechanical keys to ensure fail-safe operation. But if we look in the closed position, closed on the left, partially closed on the right, it still was possible to close the door, and from the outside, everything seems all right. And inside, we're having trouble. This again has to be considered a major safety failure. In this example, we see the ComSafe BIBO housing with its fail-safe clamping mechanism, including a double safety feature. It uses a rounded single action lever. The roundedness is to make us for a smooth operation inside the bag, and it's of course completely toolless. But what's important, it is strictly impossible to lock or even move the clamping lever if the filter is not correctly inserted. And then it is impossible to close the door if the clamping lever is not in the fully locked position. So a smart design can be really very simple, and it will be all the more reliable for it, of course, while not only encouraging but enforcing through design the proper execution of a safety critical operation. Another helpful feature in the validation process of a containment HEPA application is a mobile integrity probe. Usually it's an option. It is a HEPA integrity testing device that gets integrated directly into the housing, and you may recognize it by the access ports an upstream concentration port and a downstream port to the mobile probe, which is here hidden under the cover. That makes things easier, quicker, cleaner, safer, but for best performances, you should combine it with a particle injection module. Why is it easier, quicker, cleaner, safer? Well, you don't require access to upstream, downstream ducts. Everything is handled from right in front of the housing. There's no containment rig required to check your filter. And yes, the system is generally more sensitive and accurate than global efficiency evaluation. And how does that work? Here is a little schematic that is, of course, highly simplified to highlight the fundamental differences. But you get your classic air duct with aerosol injection, 100% concentration port just upstream of the filter, and the downstream sampling, in this case, for the example, static. And when we inject particles, conventional wisdom says you should inject upstream at a distance of 5 to 10 times the duct diameter in order to obtain a suitable aerosol distribution. And in the ISO 14644, they say variations should not exceed 20% in dispersion and no more than 15% over time. If you get something like you see here on the screen, that means it's either too little aerosol or you inject way too close. And then, of course, your diffusion is insufficient. Your 100% is unreliable. And if you have a little leak stream somewhere on the side, this is, again, a different issue. And even a little leak stream might be too much for a H13, H14 filter. Depending on the position of this leak stream and the position of your static probe, you just might not get it. Typical compensation attempts involve great amounts of aerosol. But the only thing you achieve by that is getting your upstream duct wet. Only thing is, full coverage, it looks really nice here, does not mean a good distribution. So once again, your 100% might still be unreliable. And the same goes for your leak stream. As I said, it's an independent problem. And even if you're using a shaped probe to cover more points in the airstream, you'll only get a better chance, not a guarantee. In contrast, this would be the situation when you use a mobile probe and an injection module. In this module, you get a multi-point injection and, well, let's call it a mixing chamber. This module ensures you get a good diffusion with lower aerosol amounts and a clean upstream duct. And by extension, your 100% measurement will be reliable. And now that we have a mobile probe, we get to sample the full airstream section, not at one time, but progressively. But yes, you will also get a reliable efficiency and a reliable leak detection, even an approximate leak location in optimum cases. We would actually like to know your opinion on that. So from your perspective, this type of technology, the mobile integrity probe, is that a feature of the future more and more, or on the levels and for applications we know today? Or do you consider this actually, no, this is from yesterday and the technology is going down? Thank you very much in advance.
Okay, so let's continue with some example.
Yes, so after those more technical issues, I'm waiting for the page to load. Sorry for the little waiting time. We are actually nearing the end of the webinar, and after those little technical excursions, I would like to illustrate what I meant when I said earlier, half of the time the solution would not be so straightforward. We're going to show a few examples from our project activity at Camfil European Metal Center. And keep in mind, all those are real-life projects and are composed of minimum 80%, usually more, from totally standard modules. In practice, the possibilities are almost limitless. So some project examples for modular BIBO-safe housing systems. Horizontal flow banks. Here you see a little closer picture of a wall-mounted one. Crazy things for very, very constricted spaces. And bottom left, a combination with 2-to-1, because in the middle we have a molecular filtration stage where the airflow needs to slow down for the adsorption process. And then, of course, also terminal housings. This is, well, per definition, not so much modular physically, but even if the options impact the actual housing body, the approach is still modular in design and does bear the same fruit. And in those examples, we have an interesting insulated one for cold process air, Armorflex Insulation X-Works. And top right, an example of a refurbishing project where we had to match a specific building interface. And then there are more exotic variants. The takeaway for you that I would like to see is you should not hesitate to contact us, even if the standard range in the catalog does not fully fit the bill, because there's a good chance we can make it fit. And for the latest tendencies that we have observed, without, of course, claiming to be representative, we would share the two following ones. We've seen two features. One is horizontal flow BIBO housings instead of the more traditional ones. Things you get a smaller footprint in square meters. You get a certain ease of dimensioning and customizing the outlets for airspeed that comes with some disadvantages for ergonomy. The customers who selected this did not bother. And the second point, we see a really strong increase in scanning applications. So it's the mobile integrity probe issue again. This might come from the latest edition of ISO 14644, where they say for critical processes, without detailing that, scanning is suggested now for both extract and supply air housings. In any case, it can be made available for all airflow orientations, horizontal, vertical, in both. And it's suitable for exhaust and supply air. And finally, there is one very last interesting issue that has surfaced. Fabrice, would you please?
Yes, absolutely. Thank you, Volker, for this interesting highlight. The 3D drawing have shown interest these last years, and requests come daily to our engineering departments. So let's see how we can support you in this designing project phase, and let's see what kind of answer we can bring. So our answer today is to provide a STEP format simplified. STEP is a transfer format from and into any 3D CAD software. It's created directly from the project 3D. It is light because simplify, I mean all non-essential for your integration has been removed. It's available for any project or product. And our commitment today is to supply a 3D step drawing in 5 working days when the product definition, of course, has been finalized between us. But we would like to take opportunity to have you online to launch our latest poll of the day, which is related to the 3D. So imagine that you have access to 3D drawing, as I explained, a STEP format or a DWG format. How important are Revit files like RFA and or RVT? Is it something very important for you? Mandatory. Is it a nice to have? You do not need Revit files in your project or in your daily business, or simply you cannot answer because you do not deal with CAD story. So we are looking forward, and we thank you in advance for your answer. So it seems that it's very important, 45%. Interesting. Thank you very much for your input. So now we are touching the end of this webinar. So let's revert back now to the challenge that business face. Number one is, of course, the compliance with standard. So the message would be, don't hesitate, ask for traceability, ask for test report of any proof that might secure your project. Looking back at the second challenge, operational performances, mainly based on product design. The third aspect was about the modularity and flexibility. We saw how a core DNA and strategy was key to bring the fast answering market expect. And of course, the user friendliness was covered following observation and insight coming from users. And I am sure some of you have already contributed to improve and develop new solutions with us. So I thank you very much for that. Let's see if we have few minutes for few questions. So we have a question related to the powder coats. Does number thing the raw material? Yeah, of course. We can supply different color, not only 9010. Okay. Any more question? Okay. Okay, so I take opportunity to thank all of you which has been attending to this webinar. This webinar has been recorded, I think, and for your question, we will come back to you individually. So Volker, thank you very much for your presentation and time, and thank you everyone, and take care. Bye-bye.
Thank you. Goodbye, everyone.